Twist is an application which enables the creation, editing and transformation of sound within a browser. It's inspired by experimental sound design tools such as Cecilia, Mammoth, SoundShaper and Composer's Desktop Project, and is geared towards short and intense destructive sound changes, some of which may be too computationally intensive to perform in real time. It also has typical wave editing capabilities, is scriptable and is straightforward to add new transforms using Csound and JSON. Audio processing is carried out with the WebAssembly build of Csound, so thank you to everyone who's made this possible. This video will walk through some capabilities of the current version. The application URL is twist.1bpm.net, which is also in the video description. Visiting this leads us to a page which we have to click on to start the application. After a short delay, a dialog will appear on the first run, giving some tips on usage. On every subsequent run, we'll see this dialog which asks for a file to be dragged in or gives the option to create an empty file. So I'm going to drag in a file. This is a WAV file. Twist will accept anything that Csound can handle, which includes MP3, WAV, FLAC and AAF. When loaded, it looks pretty much like a standard wave editor. This is a mono file. As you can see, there's only one waveform. If it was stereo, the left and right will be stacked on top of each other, which we'll see later on. Clicking on the waveform will set the play position. Clicking and dragging will set the selection area. Shift clicking will extend the selection area, and moving the yellow markers at the top will allow the selection area to be adjusted. There are zoom controls in the bottom left, which include zoom in, zoom out, show all, zoom selection, and then the scroll bar at the side there can be used to scroll through the sound accordingly. Twist has clipboard functionality, which is available under Edit menu, as shortcuts on the keyboard, which are shown on the Edit menu, or with the icons below the waveform, which include cut, copy, paste, paste special and trim. So I'm going to copy this selection with Ctrl C and then put that over here with Ctrl V, and we can hear that in action by pressing the space bar, which is a shortcut to play. That's also available underneath the waveform here on the icon bar. Some of the other icons down here include rewind, which moves the play head to the start of the waveform, audition, which allows us to preview a transform, commit, which applies a transform, and record, which lets you record in from your computer line in or microphone. So I've pasted that in there, and I'm now going to undo that using undo on the edit menu. Twist does have a limited undo functionality. As it's a browser application, it doesn't have access to disk caching, so an unlimited undo functionality with an excessive number of actions performed could actually use up all of the memory. A number of undos can be changed in the settings pane under the options menu. We can see here that undo levels is set to 2, which is the default, which is enough for me personally to realise if something needs to be undone or not, but that can go up to 32. Hovering over the text on these setting items will tell you a bit about what they are. So here we can also set the theme visually, and also control the number of operations that are logged as scripts, which we'll see later on. And we can set the analysis type to frequency or oscilloscope. You can show the shortcuts bar under the waveform or not, and then apply DC blocking and 10H limiting to everything that's done in Twist, which is on by default. Twist can also save the file before a commit's applied. Twist can also automatically save the file before a transform is committed if this box here is ticked. Depending on how the browser is configured, it will either ask you where to save the file or save it to your downloads folder. So this can offer an alternative to using undo levels, because everything that you do will be saved basically. That covers most of the basic actions, although one thing I've not demonstrated is the paste special on the edit menu. So So I've selected this region now, I'll copy it with Ctrl C, and then I'm going to paste it in at the point that I've positioned it there. You go to Paste Special, and this gives us two other parameters for the paste, so we can actually mix paste it with what's already there, and we can set the number of repetitions, so the number of times that it's pasted sequentially. There's some icons next to these parameters as well, which are common icons throughout Twist, and we'll see further on in the video. But these basically allow the parameters to be reset to default and included in randomization. So that's determined as to whether it's highlighted or not. And then the actual randomization is carried out by clicking the icon in the far top right there. It can reset all of the parameters to the default with the reset parameters icon in the far top right as well. So I'm going to set this to paste in 10 times. So you can see that's occurred there now. All of the actions involving clipboard, selection and zoom are available under the Edit and View menus with the corresponding keyboard shortcuts. And the playback, commit and audition options are available under the Action menu. Under the View menu as well, we've also got Toggle Analysis, which will toggle the analysis type that is specified in the Settings panel. So when I play this now, we should see a frequency analyzer above the waveform. This can be changed to an oscilloscope as well under the Settings menu. That covers the basic operations of Twist. So now I'll move on to looking at the transforms. The core part of Twist's sound design capabilities are transforms. The available transforms are listed in the pane on the left, and this is a kind of tree view menu sort of system. So we can see these are categories here. So under filter, if we click on this, it'll expand, and we can see we've got some typical filters there. Hovering over these will describe what they are. So we can see we've got Butterworth low pass, high pass and band pass filters, Moog emulation, TB303 emulation, etc. And some of them have got significantly more in than others. For example, frequency has only got a few in, whereas spectral we have quite a few things going on. So you can actually load these up by clicking on the individual transform item. So if I load up the Butterworth low pass there, we'll see this is one that's only got a couple of parameters. The frequency of the filter, obviously, and the apply mode. So we can hear this operation by auditioning it, which we can do with the audition shortcut here, on the action menu, or with the enter key. So let's contrast how it sounds normally by pressing play to auditioning it with a low pass filter at 633-ish Hz. The parameters can be changed by using the slider where appropriate, drop down menu, or next to the slider you can actually type in directly the value. So I can set the low pass frequency, for example here, to 750. Apply mode is a parameter that is available in most of the transforms and denotes how the transform will be applied to the sound. Usually it'll be replace, which just replaces the original with the affected version. But we can also specify mix, which brings up an additional 2 parameters of dry and wet mix. So we get the original mix from the sound and the output from the transform. We can also modulate the output from the transform with the original, or demodulate it. This will be a bit more demonstrable if we pick something, say for example like a reverb. So we use the Beberverb here, which is a physical modelling reverberator, and actually allows us to specify a virtual room in a number of meters, and then the position of the listener as such. So if we just have a listen to this with the default parameters, you can hear that's fairly excessive reverb. I'm going to turn some of these things down. Also, what we'll be hearing here with the reverb is just the wet mix, because it's on the replace apply mode. That's also now a little bit close sounding. It sounds a little bit digital, but we can tweak these accordingly. By changing apply mode to mix, we can now change the corresponding dry and wet mix. So with the dry mix to 0, that'll just be the same as the replace apply mode. If we have dry up to 1 and wet down a bit, that's typically what we might expect with how we'd use a reverb. And that sounds a little bit more cohesive than it being on its own. Using modulate will actually modulate the original with the reverb output, which is kind of crazy, but let's see what that sounds like. Modulation usually results in a slightly lower amplitude output. You can also demodulate it, which usually results in an excessively loud output. And I'm not going to preview that, but I'll let you do that yourself. You may notice that different parameters have got a slightly different set of icons to the right of them. So for all of them we have reset and including randomization, which is the same as what we've seen under the paste special menu. So I can reset these to the original quite easily, also using the icons in the far top right here to reset all of the parameters to the original, or randomize the ones that have been selected for randomization. So for example, if we unhighlight all but the top 2 and then click on randomize parameters, we'll see that only those 2 are randomized. When auditioning, you'll see a tooltip pop up over certain parameters, such as these: room width, room depth and room height, which are the ones lacking the additional icons, which are automate and modulate. So the parameters lacking those additional icons can't actually be changed in real time and won't have an effect on the sound until it's played back again. So you can see there it says changes will be applied upon next run, whereas the others can be changed midway through. I'm going to go to the frequency shifter now, of which there are actually 2, but hovering over those will describe what they are. So frequency shifter 1 is a Hilbert frequency shifter, and frequency shifter 2 is a biquadratic algorithm. So by auditioning this now and altering the shift, because it's one that can be changed during playback, as we have the automate and modulate icons, we'll hear a difference as it's playing back. It's also worth noting now that using the loop playback tick box here, we can loop the playback or auditioning of a sound while it's being worked on, so that even the parameters that can't be changed midway through will be applied on the next loop point. Also, the transform loaded will be applied to the full waveform if nothing's selected, or the selection area if something's selected. So for example, this section here will be played over and over again while I get this right. When you're happy with it, you can actually use the commit button or commit on the action menu or Alt and Enter to destructively apply that change. And then we can listen to that back with play. The The area that the transform has been applied to can also be subject to crossfading using the crossfade sliders here. And the region that will be applicable to will be displayed on the waveform there. So we see here the effect that will happen is that we'll hear the dry mix slowly fading out to just under midway, by which point the frequency shifted version will have faded in and take precedence and then fade out again. Let's see what that sounds like. It's also perhaps more audible if we select a reverb and set that to a really long time. So that can be useful for blending sounds accordingly. That demonstrates the basic transform usage, and next I'll move on to the usage of modulation and automation. These graph and waveform type icons at the side of some of the transform parameters will show automate and modulate when hovered over. Not all parameters have these, as I've described before. This is only applicable to parameters that can be changed during the playback of a sound. I'm going to go back to the frequency shifter and select a region of this waveform. Modulate and automate will allow us to time vary a given parameter. So we look at modulate first, and by clicking on the icon here, it replaces the shift slider and input with this area, which allows us to specify a type of modulation to apply to it. If we want to get out of this, we can just go to the close modulation button here to the far right. Modulation types available are fairly straightforward and listed in the drop down here. Some of them are greyed out because they're not available. The cross-adaptive modulations require another file to be loaded in order to analyse and inform the modulation. These I'll look at in the advanced section of the video later. The modulations will work as you may expect, so LFO will apply LFO to the frequency shift with the given rate and waveform gain and base value, which we can preview here. Most of these can be changed in real time as well, so if I loop the playback of this, we can hear some changes to that. We do have a slight processing delay in repeating the loop each time there. So LFO is an LFO. Line allows a line to be drawn between the start and last point of the selection area. Obviously then selecting a smaller area will apply the same thing but in a short amount of time. So that can be quite useful to keep that in place but select different regions. The remaining three, random, jitter and parametric jitter, are types of aleatoric or random modulations. So random is fairly straightforward in that we set the rate of change, the minimum frequency shift that we want and the maximum frequency shift that we want, and then we can also set a glide between the changes which occur at the rate in hertz. I select a slightly larger bit there, well all of it, so we can actually hear that in action more. So jitter and parametric jitter give a bunch more parameters on how to control the randomness. So with parametric, just for example, we've got multiple overlapping random factors there. Here's some quite interesting effects with those. Clicking on the automate icon will bring up a spline editor which can be used to draw in a curve for the given parameter. The very first and very last points can't be changed in time. We can change the value up and down of those, but the x-axis can't be changed. We can add in new points by clicking anywhere, clicking and dragging those accordingly, or pressing delete on a selected one in order to remove it. The selected area of the waveform can't actually be changed by clicking and dragging on it while the spline editor's up, because it's in the way, but the yellow handle that's up there can be used, so we can reposition the area that's selected without having to close the automation. Where the automation icon was, we see we can close automation, which will stop the automation being applied. However, if I open that again, we see the spline still there, and it's possible using the icon that's now appeared in the top far right to hide the automation but keep it active. So upon clicking this, the icons at the side of the shift parameter haven't changed, but there is the eye icon here, which when clicked will make the automation reappear. So essentially by clicking the close, it stops the automation being applied. Clicking hide lets you go back to the waveform and change the selection area more easily and things like that. But the automation will still be applicable. Like if I audition here now, we'll hear the curve that's been applied, but we just can't see it. This is particularly useful when there are multiple parameters in question. So if I go back to reverb that's got a couple of parameters here, for example this, where we've got decay time and high frequency damping, we can draw in splines for both of those. So I'm going to make the reverb time go up and then make the high frequency damping go down. So we can see we've got both splines visible there. We choose the active one, which is to be edited by clicking on the eye icon at the side of the relevant parameter, which will make it come more into the foreground. As I've just described, we can hide those and they'll still be applied, and then we can view those again by clicking on the eye icon accordingly. Let's see if that sounds interesting at all. And then we can close the automation with the close buttons. Obviously it's possible to change a bunch of these independently and have multiple things going on at once. So it's possible to automate something and modulate something else, modulate multiple things, or automate multiple things. That basically summarises the application of automation in Twist. Getting quite bored with this sound now, so it's time to look at some of the more interesting things that we can actually do on a practical basis with the sound. So I've selected the window reader transform under the warping menu. This allows us to read back the sound in a time and pitch independent manner. The first parameter here is read mode, which gives us linear, which is just straight ahead. Reverse is backwards. Direct lets us actually control the read position from the file. And scale allows us to expand or compress the time. So if it's just linear and pitch scale's set to 1, it's not going to be much different. I just want to apply this to this bit here. That's just the same. So I'm going to demonstrate the direct read mode here, which is kind of interesting because that allows us to select the relative point within the selection area that is read. So if we play that now, moving that around will actually move the read head position, which is pretty much totally useless on its own, but it gets interesting when we apply modulation or automation. So for example, if I open up modulation for the read position and then set this to random with a minimum and maximum of 0 to 1, which is the relative ratio of the selection region, we should see the read head moving around doing some pretty crazy stuff. So it's kind of interesting already, actually. In fact, I'm going to take this again and have a couple of copies of this because I want to do my original idea, and then we can do this random thing here. I'm going to change the pitch scale with modulation as well, and that's going to also be random, but it's going to have a maximum of 1.5, so it will only be allowed to go up to half an octave above its current pitch, and it can go down quite low to a tenth. And the window size and window randomness, etc., control the reading of the sound, which uses the underlying sound warp opcode in Csound. It's got exponentially more interesting all of a sudden, so I'm going to commit that and go back to this first bit here. And what I actually originally wanted to do was to time compress that and put a pitch shifter on it. So I don't care for all of the things that I've opened up here, so the quickest way to reset the whole transform is actually just go back to the menu here and click on Window Reader again. For this I want to use scale, which will allow us to use time scaling. Obviously increasing that will stretch the sound out like this. That's got very low window size there, so putting that up should make it sound more legible. In a manner of speaking. And then reducing that to below 1 will time compress the sound. I want it quite short, not that short. Obviously the window size will have a significant effect on the result as well. That's fine, but I want the pitch to reduce as well, so I'll use automation to do that. And we can tail this off towards the end here. It's not quite as punchy as I wanted, so I'm going to start the pitch much higher up and then make it descend. It actually sounds like the pitch is increasing, which I think is an artifact of the windowing that's applied. So it's not quite doing exactly what I want, so I'm going to go to the FFT reader, which is very similar to the window reader, but does it in the frequency domain. And I'm going to set the scale to similar to what it was before. I think it's about 0.12 or something like that, and then the pitch scale again is going to decrease. I'm just going to use a line this time instead of automation, and then the FFT size I want quite low in order to accentuate the percussive quality of this. So let's see what that sounds like. That's more like I was expecting, but we want the time scaling to be slightly longer. That'll do. So I can apply that. There's a little bit of a gap there that I don't want, so I'm going to just highlight that, press delete to remove that. and see what that sounds like. That's quite good. This bit here is kind of goes on a bit. It's a little bit uninteresting in a way, so I'm going to apply some various effects to that, but keeping the general structural integrity of it by applying what I'm doing with the crossfades on it. So for example, this bit I'm going to shift down with the crossfades to minus 430 sort of area, and then another short bit afterwards, take it down even more, and so on. And we can see what that actually sounds like. This last bit could sound good with a massive reverb on it, so I'm going to select that. Actually only have the crossfade out, so the reverb will actually fade out by the time the file ends, and use the physical modeling reverb here. I need to set the mix to have the dry and the wet there. And actually probably going to remove the sounds here at the end, which I can do under the generate menu, and go into silence, which is a completely parameterless thing, but basically will replace the selected area with silence when it's committed. There's a little bit of sound here at the end that looks a bit like it doesn't fade out completely. So I'm going to select that area there and use amplitude from the amplitude menu to automate the gain, modulate the gain. Sometimes it's easier if there are just 2 points in what you want to automate, just to use the modulation and use line. So we can just set that basically to fade out. Zoom out again, select this last bit here and go back to the reverb. Make sure I've got the crossfade out on. That's okay, it could do with a little bit of tweaking though. That sounds kind of horrible in digital, but I'm going to keep that and see if we can do anything with that. And the first thing that comes to mind is just kind of a pitch alteration, which you can find under warping again. Spectral pitch shift is useful in that we can preserve formats with it. Sounds workable. It does sound workable. I quite like that low thing there, but I'm also keen on seeing what the Hilbert transform pitch shifter is like. Actually, I think that's even better actually. So let's see what it's like mixed with the original, with the dry slightly lower than the transform output. That's cool for the moment, so I'm going to commit that. Let's have a listen to what this sounds like. I've started a new twist session and I'm going to have a look at the scripting capabilities now. I'm going to do this by creating a new file and generating a basic tone. So everything that is done in twist is actually logged up to a certain point, the certain point being the number specified in the commit history limit here in the settings. If it's set to 0, that means that it will infinitely record the actions that are performed in twist, or we can set it to a fixed number as well. So when we do something that's controlled by the parameters in the transform interface, there's a textual representation of what's just been done that is stored internally, and we can access that, edit it, and write our own scripts basically. So I'm just going to generate a tone here that rises with the use of a modulation from 440 to 880 Hz, and that's going to be a soul wave. So So commit that, and it sounds like that. If we go to the action menu and then to scripting, or use the keyboard shortcut Ctrl K, this brings up a pane which shows a large text box and nothing in it for the moment, but there's some buttons at the bottom including load last and load all. So if I click on load last, this shows us the last transform that was carried out. And we can see here that the name is oscillator under the generate menu, and then the various parameters are contained under the channels key. Obviously this is a JSON object, so it follows a fairly standard format. We'll see the frequency is set to 440 here, but because this was automated, the automation is specified under the automation key, whereas we can see it's a line that's been applied. Then the actual values of that line are included above under the channels key, which are prepended with this term here from the automation key. So you can see here that we've got the TF gen tone freq 0 with first and last with the values that we've set to 440 and 880. That basically means that this frequency one is redundant. And then all of the other parameters that have made the waveform result in what it is after we committed it. If crossfades were used, those would also be apparent under the crossfades key here, and the selection basically determines which part of the waveform was selected, which is relative between 0 and 1. 0 being the start of the waveform, 1 being the end, and then the third index in the array here is the channel that has been selected to apply the transform to. So if it's -1, that means both channels, or just the one channel if it's a mono file. If it's 0, it means the left channel. If it's 1, it means the right channel. So I'm going to close this, but create a new file and then go to the scripting again and make some changes to this. So I can change it to go from 440 to 220, and I'm going to actually just apply this to half of the waveform. Down here we can actually audition and commit this as well. So for the purposes of this, I might actually just set the selection even smaller, so we just get a small snippet when we audition it. So you can hear there's the line between 440 and 220, and it's for 0.1 ratio of the whole length of the waveform, which is, I believe it was 10 seconds. So if we set this to 0 to 1 and then commit this, we should end up with a waveform that has a saw wave descending from 440 Hz to 220 Hz. So that's worked as we expected. I'm going to apply a few random effects to this, or things that I've chosen randomly. One of them is going to be a frequency shifter to -440. I have a bit of a crossfade on this, and just apply this at various points through the waveform, so we can then observe multiple scripted operations. So putting a few of these at different frequencies, and then finally one that is a different apply mode. So that's going to get mixed in with slightly less of the dry than the wet mix. Now if I go back to the scripting pane on the action menu, and if I was to click load last, we'll see something completely different there. We can see the frequency shift that's just been applied, and we'll see that the shift frequency is fairly obviously there. The apply mode is the index of the drop down box there, so that goes from 0 to 3, 0 being replaced, 1 mix, 2 modulate, and 3 demodulate. So those correlate to the scripted actions here. And then we can see the dry and wet mix that I've specified there as well. Also the crossfades is a ratio of the whole, and the selection being the bit that I just selected. So I can audition this and then we'll actually hear this. Obviously I've applied this, I've committed it to the waveform, so if I audition this, we'll hear basically the same thing applied to the same region, which I can't tell if it's working or not really there, but if we extend the selection out and maybe reduce the crossfade, we might hear something slightly different. So you can tell that because I started the selection earlier, set it to 0.1, it's giving us a larger segment of the waveform. Also down here we've got load all, so if I click on that, that'll load all of the scripted actions from the history, and obviously that depends on the number of actions specified in the settings menu. But from here we can see this goes right back to the first thing that I did, which is the oscillator from 440 to 880. It's also worth noting that if we commit something from a script, it isn't stored as a script. So only things that are done through the user interface with the sliders and other access to parameters are stored in the script history. But basically here you can see where I've applied the frequency shift to different parts of the waveform. Now this can't actually be auditioned because only single scripts can be auditioned, whereas upon clicking load all, we'll notice that this is actually an array of JSON objects, whereas clicking load last just gives us a single JSON object. So single JSON objects can be auditioned or committed, and arrays of them can only be committed. Obviously we can take this and copy and paste it, edit it in something else, or save it and use it later on. But I'm going to take some of this and remove the actual oscillator that I created, and just keep a few of the frequency shifts here, but change some of the selection regions, and we can see what happens there. So I'm going to change this so it's quite near the end, and change the frequency shift so it's something wildly different, and do this to each of them. The crossfades are ratios that are relative to the selection area, so those will always give 0.1 of the selection area rather than it being an absolute value that has to be changed when the selection area is changed. So it's possible using an external editor or something else to generate scripts for twist, or just save some of your favourite transforms and then reapply those to other things. Obviously if we make some sort of mistake in this, or it's not valid JSON, it won't be accepted, or will cause some rather unexpected results. So for example, if I just put in these characters here that are not valid and try and commit that, it says it can't parse the JSON. If I remove those, we should have something valid with these increased frequency shifts and the changed selection areas. Now commit that and we'll see it's applied multiple different transforms sequentially there, as we saw the progress bar move 3 times there. And this is what it sounds like. I don't think it's going to be anything particularly interesting, but that gives an overview of the capabilities for scripting within Twist. All of the individual things that we'll see in the script, for example, if we run this and then have a look, I have no idea what that's even going to sound like. Some very high frequency content there. But if I look at the last script here, most of the parameters are quite self-explanatory. And we notice that all of them, apart from apply mode, are prepended with the name of the underlying Csound instrument, which is under the Instra key. So these are things that are not fully documented. So exactly what these are is not actually recorded anywhere at the moment. But it should be fairly easy to see how these named parameters under the channels key correspond to what's actually been done in the transform from the user interface itself. It's possible at some point, if the scripting is used and there's demand for it, that they could be documented, but at the moment you just have to have a play around. In Twist it is quite simple to add new transforms with some Csound and JSON code. This is fairly well documented if we go to the Help menu and then to Developer Reference. This will open up an additional page which gives us details of how to write new transforms for Twist in fairly significant detail with some examples. So this covers quite a lot, but I'm going to show a few demonstrations, and these require some familiarity with JSON and with Csound as well. So this all happens under the Action menu under Developer. And I'm starting with nothing here, so I'm going to create a transform, really simple transform that just generates some audio. So if we go to Developer, we have two boxes here where we need to put in the Csound code and the JSON transform definition. Going back to the documentation, if we look at this, I'm just going to skip down through this, which gives us a detailed description of all of the keys that we require in the JSON and the conventions that we should adhere to for the Csound instrument. Basically, that being that each transform should be only one Csound instrument, and it's run in a k-rate loop, so things involving schedule and other asynchronous approaches outside of the single instrument definition need to be avoided in order for them to work properly. This is all detailed under the rules and style guide part here, which tells us various things about it. So there are certain things like we should have a very specific naming convention depending on whether they generate audio or use direct input or access the underlying table of the audio data directly. That's basically that the names should be prepended with TWST underscore TF underscore. If they're a standard transform, and that should be TFI if the direct table access is required. And basically that's because when we have an area selected and we're using something like an opcode such as sound warp, SND warp in Csound, that requires the F table of the audio as a parameter, and if only part of the waveform is selected, then the instrument containing the sound warp opcode needs to have a sliced version of the table that Twist is using. Also, the first line of the instrument in Csound must have this macro expansion to mark it as transform. And then if we have any other UDOs that the instrument uses, which are perfectly fine to use, so even though we've got a single instrument definition, we can also have additional UDOs and other instruments. They should be prepended with the name of the initial instrument. Now it's also worth saying there again that while we can use other instruments from the actual initial instrument, that those can't be used with schedule or event opcodes, because those actually run in asynchronous space. So one of the only real ways to call additional instruments from the initial transform instrument is to use the sub-instra opcode. And that's because of a limitation or a feature that enables Twist to perform faster than real-time operation in applying commits to audio, which happens in a K-rate loop. And each instrument must be capable of emitting stereo audio signals and using some of the helper opcodes, which we'll see in a moment. The outputs may be silent or the same as the input, depending on whether the left, right or both channels have been selected. But for the moment, we can have a look at the opcode reference here, and have a look at the first one, which is one of the helper opcodes, TWST param, and that gives us the value of a parameter from the Twist UI. So let's have a look at the actual examples here. This is a very simple oscillator, and the JSON definition here is a JSON object. The key name gives us the name which will be shown in the Twist UI. Instra should correspond to our instrument name in the Csound code up here. And the parameters is an array of JSON objects featuring various keys which are detailed above. But if we want a slider, for example, we'd have as a basic state the name, the minimum, the maximum and the default values. So this is basically just giving us one parameter called frequency, which can be scaled between 20 and 8000 but starts at 440. If we look at the Csound code here, we'll see it begins with the macro as stated above, and then we use this opcode here, TWST get input, which gives us a feed of the left and right signals from the current waveform, and then two flags, I left and I right, which tell us whether the user has requested the left channel, the right channel, or both to be processed, which corresponds to what's actually selected on the waveform view at the given time. And then the TWST param opcode here gets the value of the named parameter here, and the name specified there should correspond to either the lowercase version of the name in the JSON parameter definition, or it's also possible to have an additional key there specifying channel, which tells us the channel there. So basically this is just getting the frequency from the UI, it's getting whether it should be doing the left and right channels. This is actually generating audio, so what comes from the input in terms of AL and AR are not actually used, but this then simply generates a sine wave using the oscill opcode passed with the frequency from the UI and then outputs those. So I'm simply just going to take these for the moment and paste them in here. So paste in the Csound code in the top here and the JSON definition in the bottom. It's probably easier at the moment to edit these externally and then copy and paste them in because we don't have syntax highlighting, but it's possible to expand these so we can see what we're doing more easily. Once we've pasted both those in, we need to actually click the buttons underneath, which will inject the code into Twist. So I'll load the Csound orchestra code. This can be done in either order, it doesn't matter at all. We've got a success there. If there was an error in it, we'll see obviously some sort of syntax error displayed. So that means that this TWST ETF example OSC instrument has been loaded to the running Csound engine, and now all we need to do is load the JSON here. So we've got success messages for both of those, and if we exit this, we should now see an additional menu under the transforms tree view called develop, and that's got the name of the transform that we've just created. And we can see we've just created a single parameter there with the frequency, and that's basically just going to do as we expect. It'll oscillate at the frequency specified. So let's see if there are any more interesting examples here that we can have a look at. There are quite a few other opcodes here which are useful for doing things in Twist and creating transforms. So for example, this one here will get the input similar to the opcode that we just looked at, the get input, but this will actually obtain it as fsig for spectral processing. And then we have some additional opcodes for spectral processing and resynthesis, and then obviously with this getF input opcode, it requires an FFT size, so that's all included within what that opcode does, and anything using that we'd expect to have a FFT size available. That's actually handled under a special type of parameter which is called a preset group, and that's detailed above. So basically with this we would see under the parameters here there would be additional things created for the specifics of phase vocoder analysis and resynthesis. So I'm going to try that actually and see what happens, and go back to the developer page, paste in the Csound code, go back and paste in this JSON, and again it doesn't matter which way those are loaded. It looks like there's actually an error with the example there, which needs to go correct, but that was fairly easy to spot. It's just this right PV scale here didn't have R on the end, it just had L. So that's worked now, and hopefully we should be able to go back and see that we've now got something called repicture in the transforms menu under the develop group. It's worth noting here that we've got one parameter, it's pitch scaling, but what we should see upon going to the repicture here is that we have a bunch more parameters which are related to the phase vocoder analysis and resynthesis. So basically by specifying those preset groups, PVL and PVSynth, we get a bunch of extra parameters included that automatically maps to how the TWST getF input opcode analyzes the incoming audio, and then the PVSynth parameters are related to how the TWST TF resynth opcode works. So you can see there basically the top view. Actually the top all but one are related to the analysis, and then the bottom one, resynth mode, is just a drop down that doesn't have any additional parameters unless we specify additive, which then brings up a bunch of other parameters that we can change things to do with the resynthesis. So there are quite a few shortcuts with what we can do in creating new transforms there, and there are quite a few examples on this page, so I'm not going to go through all of these because this is probably its own separate video which would take quite a long time to go into the specifics of it. But if you have some Csound experience and familiarity with JSON, then there's quite an easy opportunity to get involved and make your own transforms for that basically. So at the bottom of this page as well there are the transform definitions and the Csound code from the live application. So using the links here and these categories here, we can actually see the Csound code and JSON which is used in the live application, and would be quite useful to examine in order to get an idea of the approaches to creating your own transforms in Twist. In this last part of the video, I'm going to have a quick look at the advanced transform capabilities in Twist that we've got, and I'm going to go pretty much straight in at the deep end and load in a couple of files which we may be already familiar with. I can't actually remember if I've mentioned, but we can have multiple files open at once by clicking that little plus sign in the bottom left of the waveform there. I'm going to load in two things, which are a glass hit or smash, and then the sound of some crockery rummaging about, which I've heard a lot of, I think. So one of the first things I'm going to look at in this sense is under the cross-processing menu, and is actually one of my favourite transforms, which is concatenative resynthesis. Now this works by taking a corpus which is specified under this drop-down box here, and depending on the one that's open, it'll be the other one. Basically, we can't have the corpus the same as the file that we're applying this to. Concatenative synthesis basically works by analysing the corpus input, then playing back the target, analysing that as well, and finding the nearest perceptual match from the corpus. Technically this actually works using MFCCs, so we've got a few parameters to control that. And basically what that should sound like is small segments of the sound are replaced with similar sounding things from the corpus. So with this, for example, I'm going to go to the glass and replace this with the sound of the crockery basically. So it should follow the same amplitude envelope and also have a similar frequency content as much as the corpus will temporally permit. The results can be quite dramatically different depending on the FFT size and the number of bands, which is the number of analysis bands, and then also the minimum and maximum frequency for which it's applied. Depending on the length of the corpus sound, this can be quite a heavy effect because the corpus has to be analysed fully, and then for each frame of the input it has to check every possible frame of the corpus in order to find the best match. So let's see what this sounds like with the default. And first of all, I'll just play the glass sound as it is. Let's see what that sounds like with the concatenative resynthesis. Sounds kind of okay, but we can see what that sounds like the other way around. So you can definitely hear that there's the sound of the glass there following the sound of what the crockery was. I'm going to put the FFT size up a little bit and see what that's like. And that's interesting, that's a little bit more legible. So it goes from this, but we're applying this as the corpus, and it results in this, which I think sounds quite interesting. But this could be more interesting if we use the crockery as a corpus and then bring in a little drum loop here. Let's see what this does. That's okay, but I think the FFT size is a bit too long here. So if I reduce that, and then there's a parameter here that allows us to stretch out the individual frames that match. So I'm going to put that as low as possible in order to increase the rhythmic responsivity of this. It's kind of okay, but let's see what happens if I bring in another drum loop, which sounds like that. Contrast that with this one that we've got open. And then we'll try concatenative resynthesis against each other. I quite like the sound of that, and that's something that I find quite useful to work with. So that's concatenative resynthesis. Under cross-processing as well, we have some other things you'll probably recognise: convolution, and then there are various cross-synthesis approaches as well. So morph, for example, allows us to specify the amount of amplitude and frequency morph between the instances here. Notice on each of these cross-processing transforms we have the cross instance, which allows us to pick the other file to which we're applying the effect, and then the instance loop type. So that's relevant if the current target is longer than the cross instance that has been selected. So then if we end up in a situation where the cross instance needs to carry on because the target that we're applying it to is longer than that, then that can be looped up with forwards, backwards or ping pong loop. So let's see what this sounds like with the just as it is. That sounds like completely the other file. So this is what this one sounds like. This is what this one sounds like. Go back to the left one here and audition this. We're just hearing the other file. That's because the amplitude and frequency amount are fully at 1. So if we ease these off, we should find that the frequency we should be getting from the cross instance, then the amplitude we'll be getting from this file. And it's kind of almost unnoticeable because of the nature of the sound, so I'm going to go back and then drag in this crockery file again. And let's see what that's like with this. Maybe not the best example of that. So I'm going to bring in this, which is some vocal, it's a vocal chord I think. And we'll see what happens, see if we can get any sort of interesting result from morphing this drum loop with the pitch sound that we've got. Okay, that's a better example, and we can hear there that we've got the rhythm of the drum loop, but it's also applied the pitch from the vocals that we've got there. And we can hone that in a bit more by changing the FFT size, using peak lock and changing the window size multiplier, and also the other parameters. Cross synth is kind of similar, and that's amplitude based only. Convolution is a fairly common effect, and basically this works by using the selected area of the instance, the cross instance here, as the convolution impulse. So I'm going to get rid of this again and bring in the crockery sound, and actually now I'm going to bring in the glass. I think that would be good as a convolution impulse. Now if we try and actually listen to this as it is, it's probably not going to run in real time. That doesn't seem to run in real time now. So the size ratio is the ratio of the selected area, or all if nothing selected, of the cross instance. So basically we need to go to this glass here and select part of it. So I'm going to get the tail end of that, this, and then go back to the other one, and we should be able to use that selected area as the convolution impulse for this. Again, it's quite computation heavy, so size ratio is the actual length ratio of that selected area. We can put that right down and it should run better in real time. Or obviously we can put it right up or a bit and then commit it and we'll see what that sounds like. It's nice and glassy sounding. I'm basically just going to have a look at the spectral transforms here, of which there are quite a few. Some of these are very processing intensive. So for example with the granular, this is spectral domain granular resynthesis transform, which I've created from scratch myself. This is a bit of a crazy idea and it's very highly processing intensive. This works using internally a recursive Csound UDO, and with each level of recursion it processes a separate frequency bin in phase vocoder analysis. So with a bunch of the spectral effects, we'll see that we have frequency bottom ratio and frequency top ratio. For the full spectrum effect to be applied, those should be set to 0 and 1 respectively, but that's not always feasible to play back in real time. So you can see this in effect. I'm going to tweak some of the parameters up here and change the grain duration a bit and the rate and duration randomness. We've also got the read mod here, which is always kind of a fun one which I've visited before, where with direct we can actually see the read position moving in the waveform, such as this. That's a little short, so I'm actually going to copy and paste that a few times just randomly in there. But we'll see if I audition this. It's already fairly processing intensive, so I'm going to turn the frequency top ratio down even more. It's still too processing intensive, so I'm just going to turn up the frequency top ratio right full and set this to linear read mode and then just commit that. I could be in for a bit of a wait here. The spectral opcodes have various different approaches to how they do things, but they're usually all quite novel things, or some of them are things that I've not actually experienced in other applications or elsewhere. Another one of my favourites is swap, which allows us to swap certain portions of the frequency spectrum with another, and that can result in some interesting effects and allows independent control of the regions of amplitude and frequency. So let's have a listen to what this spectral granular effect sounds like. It's a bit spectral sounding. I think the FFT size was a little bit high for that, but it gives an idea of what we can do there. I'm going to have a look at a swap now. Let's see if we can salvage this, because it just sounds like FFT mess to me now. We'll see if we can do anything crazy with it to make it interesting by checking out what default settings are for this swap. I'm just going to go crazy and modulate a few of these. So this is changing the regions of what's going to get swapped around for the frequency and the amplitude, and hopefully end up with something that'll take us in a more interesting direction than how it sounds at the moment. Well, we'll see. And then I'll apply a few other strange things to this as well, like let's see what this sounds like. I'm going to put an LF on that as well, have it fairly fast and commit that. And then while I'm here, I'm actually going to go up and use the FM model generation and set this to note mode, so we can actually specify a note rather than a frequency. And this I'm going to modulate with the original and have a little crossfade on it and see what that sounds like. Can't really hear that note coming out so much in the modulation, so maybe it needs to be higher up. Or, in actual fact, perhaps just mix with the original. So I'm going to apply a few of these and change the notes here. So using these sort of techniques, we can actually create fairly cohesive melodic things within Twist. I have no idea what this is going to sound like, but it's something anyway. Just going to keep adding these on. And hopefully I'll give something a bit more interesting to work with, and I can end this video with something that actually sounds interesting than just a mess of FFT stuff. But you never know, I might not be able to salvage this at all. So I'm just going to carry on doing this. At the worst, I can always apply concatenative resynthesis and I'll probably come up with something quite interesting. So let's see what this sounds like in its entirety. So here we've got some notes there going on, which is kind of nice-ish, but I want to do something a bit more interesting with this, and we'll perhaps just apply concatenative resynthesis using the glass as input, which is pretty crazy, but I'm going to modulate the output of that with the original. So we've got a lot of interacting processes going on there with the various bits of sound. For me, that's got quite a bit more interesting quite quickly. I'm going to tweak a few of these and see what they sound like. That'll do. So we've got something there. I quite like this gravelly stuff here, but I'm feeling that there should be something a bit more interesting happening at the start, so we'll have a little crossfade a bit there, and probably just going to do the sample rearrange, which is something that takes the selected area and chops it up into this number of segments, which can be a size of somewhere random between the minimum and maximum samples, and then just basically rearranges them randomly, so you can come out with some pretty crazy results. And this is going to be cross-faded, so I'm just going to commit that. That can be a surprisingly CPU heavy effect as well. And that's giving us a bit of a choppy sort of sound. I think this could do with the resonator, perhaps. A fairly low frequency. That's kind of okay. I'm going to bring that back in over here as well, but it's going to have a randomization on it between a couple of frequencies and be fairly fast. I'll apply that, then let's do something else to the start of it as well here, like a kind of a pitch shift, which is not going to fade in but it'll fade out, and that's going to be done using the Hilbert pitch scale with some automation that we're going to draw in here of starting high, then going low, then going back up to the 0 point again. That sounds kind of interesting, but I'm also keen on making that resonator a bit less distinct there, which will probably be best if we take the pitch down a bit. Okay, I'm getting there. Let's just go crazy. Let's just do that. Whatever that sounds like, that's what I'm having. And then I'm going to apply the sample rearrange again over here, and it's going to have like a minimum sample that's pretty low and lots of chops, and that could be quite crazy sounding, so let's commit that and see what happens. Then one of my favourite things to do in music is actually see how long you can go applying effects or changing arrangements without actually listening to it. So I'm going to do that here at the end. And it can be fairly safe by using the crossfades and things, so we get a fairly seamless interaction with what's already there, basically. That was an accident, I didn't mean to listen to that. But I'm going to carry on, just put a few more things on and then wrap up the video itself. I've started listening to it now, so I might as well just carry on. Sounds kind of interesting. And let's see what we've got into the spectral category here for a little finale. Scramble. Let's apply that there, and let's have a listen to that in its entirety. I could play with it for hours, but that pretty much wraps up all of the things that I need to express in this video. There may be future videos with additional tutorials and new techniques as new features or requests are implemented in Twist, so please subscribe to my channel if you'd like to receive updates for those. Thank you for watching, and I wish you well in your creations.